Okay, this is an overview video to an overview of line or base maintenance to pretty much try to help and determine what else or what do we need to help us understand what are the difference between the two and pretty much give a general perspective on how things works on this process. Um, like I said, this is very basic. I'm not gonna go into many details because every maintenance organization has its own set of rules and procedures. So basically, what I'm gonna do here is to start with if what can help you to determine if it's base or line maintenance. So for the people that have avionics background, they know this is an OR gate. This is pretty much symbolic in for the purpose of this video. It's just to give you a perspective of when you decide that something is go in from the line maintenance environment, pretty much after or before the aircraft fly, into base maintenance. Obviously, I'll give you also what are the basics of base maintenance, how is that determined, and so on. Um, but I want to focus more on when an aircraft goes from line to base maintenance, basically. Um, and obviously, the outcome of that will be a CRS. For those who are not familiar with the term, is the certificate of release to service, which pretty much officially the maintenance organization give the to the operator of the aircraft, um, saying the aircraft is worthy to fly again. Um, so to the first thing I want to touch on is how the process actually works. Um, the reason I want you to understand this is because you can see what is the whole system, the system as a whole, and decide and see what is your input in there. So obviously you have the aircraft maintenance certification, which obviously is provided by technical publications. Um, this is the topic of this video based on line maintenance. Obviously, someone that is conducting and certifying for that, based it on their training, on set of qualifications and competencies, a license, and obviously what the maintenance organization exposition is telling you, basically what allows you to do on which task, if it's line maintenance, base maintenance, or for a task sign off or whatever it may be. Also, there is uh, other part I want to mention is this part 21, design and production, is pretty much what I'm saying. That is the manufacturer, the aircraft manufacturer, um, Boeing, Bombardier, um, Airbus, whatever it may be. They pretty much the ones who helped to the operator to pretty much establish a maintenance program. They assist with that. That information is there, and obviously, it's a normal communication between the the let's say the operations and the maintenance organization here. And this is the CAMO, is the continuous, is I put it here in the keywords, the continuous airworthiness maintenance organization, who are overviewing the whole fleet, and they're in normal contact with the owner, or sorry, with the manufacturer, and with the operation side, and obviously the maintenance organization you're working for. So pretty much that's in a nutshell what I'm trying to show you here. But for the, like I said, for the purpose of this video, you're gonna focus on what is relevant to base and line maintenance. And like I said, the reason I'm putting this here is just to help you understand that there's a maintenance program in place, and we should follow certain basic rules and procedures for the local procedures of the maintenance organization to actually determine what is the best way to go, especially when you're in a line maintenance environment. For base maintenance, there is already something in place. It already process, procedures, schedules, planning, and so on, which is this bit here. Okay. All right. Let's start with line maintenance. Line maintenance is obviously more attached to operations. By the way, I'm putting these keywords here for your own convenience, so you can look it up and Google it and find more information without going into much detail. Otherwise, it would be too much information in one video, and that's not the. I mean, yes, it does the intent, but I don't want to overload for the purpose of what is line and base maintenance. Um, so let's start with the schedule checks, which are your normal services. You can call it the daily services, the weekly services, whatever is telling you to do in a common basis for that aircraft. Um, those are obviously, as I showed you before, they are already part of this aircraft maintenance program, which is overview by the continuous airworthiness maintenance organization, and also by operations. Operation, let's say in this sense, this could be the owner, the lessor, or whatever it may be, the premise the customer. Um, and obviously you are in this part here, and the part 145, as calling many airworthiness authorities, maintenance organization. Um, so once again, so the schedule checks is the normal routines, and they prescribe for something that is called the maintenance steering group, and or unconditioned maintenance, as we call it nowadays, which actually prescribe all those scheduled maintenance. The next thing you're gonna have in a day-to-day, or well, week-to-week, or depends on which aircraft fleet you're working on, is a normal troubleshooting and finding. You may have defects. I'm gonna show you in the next couple of slides. What I mean by that is when you got pilot reports during flight, or that events that need the input of maintenance to do a proper evaluation to keep the airworthiness of the aircraft. So, and obviously minor different rectifications. Uh, we'll see some example of that, but that's defined in your own procedure. It will tell you what is a minor task, or even the most senior aircraft maintenance or licensed maintenance engineers will tell you uh, what is considered a minor, or when in which event it should be categorized to something more serious. Obviously, that depends on your aircraft maintenance data. Also, we have um, a general aviation task, and I want to focus on this right now because you have to make the difference between what you normally do in a routine. I'm going to put you an example. 360 degrees visual inspection of your aircraft is something that is normal that you do on a daily basis, um, when not just the aircrew, but it's in the maintenance environment. But it's not in the definition of the that I put here in red, by the CAMI definition. This is the continuous airworthiness maintenance exposition definition. So they are the ones who tell you what is and what is not maintenance, even though it's in the maintenance environment. A classical example: when you do a normal window cleaning, that's is maintenance, is ongoing maintenance, or the cleaning of the cockpit or the cabin or whatever it may be. Or even in some cases replenishment of consumables. That's the day-to-day normal. We know is maintenance, but not as per the definition of a scheduled maintenance as per the aircraft maintenance program. So you have to consider that. In some areas, it's done by some other parties. It's not necessarily an aircraft maintenance engineer. But yeah, that's pretty much in a nutshell the big difference. But yeah, all these operations, all these maintenance activities are conducted in line maintenance. Obviously, the most common, like I said, the troubleshooting and fault finding. I'll show you in a minute what is the difference when you do that in alignment environment and you go to base maintenance. Now, before I okay, I think I go to the next slide now. All right, this part here, um, base maintenance. Once again, I think is prescribed by by the aircraft manufacturer, and also by the maintenance program. So the thing I want to focus is on this. Um, the reason I'm saying this is because it's different when you're doing a troubleshooting in line maintenance where you do a simple byte check or something that the aircraft maintenance data is telling you to do against something more complex that requires equipment, which automatically or not automatically, pretty much your aircraft maintenance data will tell you, okay, if it's this complex, you need to be in the hangar, you need certain equipment or whatever it may be, whatever the case may be. Um, Now, I think going to this. So I want to give you a little background because one of the keywords that show up, here, aircraft maintenance steering group, is pretty much how you improve and optimize the aircraft service of the whole fleet. And in the same token, you're saving costs to the company, to operator, and pretty much everyone wins. And not just that, but also ensure quality and safety of the aircraft that you're flying on, or I mean that you're working on. Sorry. So that's the main reason of this. You're gonna see that any database that is used for any aircraft normally use some databases. I'm gonna show you in another slide what I mean by that, um, and how complex this is, and this is pretty much the background of the base maintenance. So some words to remember here. uh, this is more like engineering, but I want to mention it here because you're part of that process. When you're doing either base or alignment, you're part of the reliability process, which is pretty much do a proper evaluation and analysis of at the component level or the system level to see what is failing to improve it or to optimize the service of the aircraft. Now, this is what I wanted to show you. So you are pretty much here. This is an authorized person. Normally, it's a licensed aircraft maintenance engineer authorized by the 145 maintenance organization, and he will release the aircraft based on all this information that you see around here. Obviously, you had a maintenance planning department. You have another organization who is in charge of the performance of that maintenance, and they all based on this. I put all this as databases. The reason I'm doing this is because this database could be internal or external. You can be using information from another suppliers, uh, and so on. So what I mean by this is if thousands and hundreds of thousands of people working on the information that they provide here, just to ensure that before you release the aircraft, you have the proper information, the up-to-date information when you certify and release an aircraft. So that's the whole purpose of this. Um, so obviously you're gonna check your own database, and all this information is already filtered for you in a way that you can make a proper evaluation. And once again, you're not gonna do this by yourself. Obviously, this depending on the internal procedure, it will tell you what is the way that you're supposed to go. More senior aircraft maintenance engineers or support engineers, they'll help you to make the right decision. But yeah, the main point on this slide is that all this is very complex, and we're talking here base maintenance only. It's a very complex process, but obviously the whole purpose is to keep the aircraft safe and with the quality that needs to be delivered to the customer. Um, and another thing I want to mention, the maintenance. We all are maintenance control when working on aircraft maintenance. Quality control is at different levels. It's what you do in your day-to-day basis. Um, is pretty much comes down to that. The information is there, so each one of these databases pretty much is thousands of people working day to day just to ensure we do the right thing. Okay, now we go with a few examples. Um, well, sorry, a few scenarios, case scenarios. So I'm gonna start with this one. Um, and I want to see the three different scenarios that we have here, and just to sort of give you a perception of what is it that can help you to make the right decision. So let's say the pilot reported an intermittent light in the landing gear, in the opposition. So if I remember correctly, um, this light is right here. So it was during flight. Obviously, the fact is that the aircraft is on ground now, and you cannot duplicate that fault. Obviously, it's very hard to duplicate an intermittent fault. But you may have three scenarios here, and that's what I want to focus on. And let's say this aircraft is in line maintenance, is going to be delivered next day, or let's say in 2 days they want the aircraft ready. So the first scenario is option, let's say, is that you do your aircraft maintenance data tells you to do your basic fault finding. Let's say a bite test or landing gear control unit or box reset, a replacement of the lockup sensor, the cleaning, whatever maybe, whatever the common maintenance practice for that case. But remember, the aircraft is in line maintenance at this stage. So obviously, the most senior aircraft maintenance engineer or support engineer will tell you or will help you to determine that. If it's something similar, obviously you follow your aircraft maintenance data, and from there you take the decision. So, and once again, if everything is fine, off you go, you deliver the aircraft, you back to the operator, and next day we'll be flying again. But guess what? Let's say, let's put the another scenario where that sensor is causing this light to go. Yeah, you can actually duplicate the fault on the ground. So you say, okay, there's something going on here. So here is where you probably had to take a different path of or be more thorough with the decision you got what are you gonna choose in this case. So let's say uh, the sensor, you need to get to the sensor and the wiring, you find something here. So more complex maintenance activities are required. So I'm putting the example of a C-130. You got some panels, so probably, I don't know, something that requires more complex maintenance activity. So that tells you in a nutshell that if more maintenance is required than the one that you were supposed to, as here, obviously that is inclining towards a base maintenance scenario. You don't know. So obviously depends on the maintenance organization. They normally take the route of consult with a maintenance engineering support and say, look, this is what happened. I could duplicate the fault, but I cannot find what it is. So we need to know. So let's say, okay, you want just replace the sensor, and it wasn't necessary to open this panel, for instance, or to remove this panel here of, sorry, fairing, and and okay, you replace the sensor, off you go, so, and the aircraft will go back to service. But let's say, okay, something more serious is going on here, and let's say you could identify there's a wiring fault, but you don't know what it is. All you know is that for the normal troubleshooting that avionics normally conduct, there is more to it, more than just a component, a sensor, or black box, or whatever you call it. So you still could duplicate that light here. So that requires that I'm gonna put you an example. I'm obviously your aircraft maintenance data will tell you that, but say, okay, you need to replace a harness that goes from here to somewhere here or whatever, and you identify already the issues between here and the cabin, for instance, and you need to replace that harness. So that tells you automatically, okay, there's more complex maintenance that is required, um, which take us to this point here. So that, in a nutshell, tells you, okay, the aircraft go to from line maintenance to base maintenance scenario now, just because more complex maintenance is required. More planning, you need to order parts, order the harness, whatever the case may be. So that's pretty much the first thing that I want you to take from this video is that decision process um, obviously requires after you consult the aircraft maintenance data and all that. Okay, the aircraft needs to be determined to go to base maintenance when it was in a line maintenance scenario. All right. Now let's go with another example. Let's say the pilot reported the main gearbox chip detector light warning came on twice. So when I say twice, it's because probably you gotta, you can reset it, and the people that are familiarized with the system is you pretty much um, reset and send 28 volts DC to the chip detector, and off you go. The metal particle just away. But let's say the light came back on again, and whatever the aircraft maintenance data tells you to do. Um, in this case, let's say for instance, okay, there is no evidence of more metal particles. The aircraft went for a ground run to see if can duplicate the fault. Nothing happened. You follow what your aircraft maintenance data tells you to do, and then the aircraft is delivered back to service. So in that case, the aircraft is still in line maintenance, and you do the other normal routine checks and whatever is required. But let's put a second scenario where there is evidence of metal particles. So you may need assistance on that. In this case, you're gonna need um, probably to do a more comprehensive study. And you see, if the main gearbox is here, other things probably need to be removed. if you need, to do a follow up or do a second um, inspection that requires to open more panels and so on. So more time is required. So the main point is, if more maintenance is required, that means it's no longer in line maintenance. The aircraft cannot be delivered in the time that you were planning on. Let's say in the next 24 hours or 48 hours, the aircraft cannot be delivered because more maintenance is required. So at that stage, obviously, you're gonna need to make the decision, or whoever make the decision, to say, okay, the aircraft go from line to base, based on that. Um, so and we got obviously the third one, which tells you the aircraft maintenance data tells you, okay, you know what, this we had to replace the main gearbox. This main gearbox has to be replaced, which means obviously it goes straight to base maintenance, because you need planning, you need parts, you need a whole more is required to replace a major component. And that was the point I was trying to make here. Major component replacement. Obviously, you need planning and other complex and logistics to make the aircraft airworthy again. All right, and let's go to the very last case. Okay, let's say the pilot reported hard landing. This is actually a good one, because hard landing requires also certain processes and procedures in your aircraft maintenance data. Depends on the aircraft, of course. This is very generic, by the way. So let's say the evidence of, as per your aircraft maintenance data, suggests that as there no other significant major components compromised, there is no aircraft structure damage. Obviously, you're gonna check that as the guidelines that you find in your aircraft maintenance data, and the wheels were replaced. You did the test that you had to do, and off you go. The aircraft go back to service to the operator. And we have this. That was this case here. That means the aircraft is still in line maintenance and is returned to the operator, back to service. And let's say you got evidence that some other minor impact could suffer. So obviously more further evaluation is needed. In this case, let's say for instance, I don't know, I'm gonna put something here as, okay, they said to you that you had to inspect some area here due to that hard landing. Uh, so more time is required to do a proper evaluation. So that's up to the process that under your MOI. that tells you, okay, for this case, you have to do X, Y, and Z. This is not in your aircraft maintenance data. This is in your own procedure in your maintenance organization exposition and your MOI. Your MOI will tell you, okay, you had to do this. You had to contact MCC, or you had to go, whatever the name is called in every company is different, support engineering, or whatever the case may be. So, and they will tell you, okay, you have to check X, Y, and Z, or other maintenance engineering input to determine that. I'm going to tell you in a minute why is this important. um, okay, and the very last one, okay, you find the several areas were impacted by, yeah, several areas impacted by structural components or major components, and then obviously it requires to be in a base maintenance environment to do a proper assessment. So um, now going back to why is this important? Because you are part of a very complex process just to ensure the airworthiness of the whole fleet, not just of the aircraft you're working on, but the whole fleet. What I'm trying to show you here is that because this is a process where you got a constant feedback, whatever you find that determines that it could be due to some component that failed, if we could identify in this case, I'm gonna just make it stuff up here, but let's say on this case, it wasn't, let's pretend it's not the hard landing, but it's probably something relevant to the transducer, for instance. If that component fell, so you give more proper feedback to the. Uh, Sorry, just for a minute. Bear with me. Okay, you get more proper information to the manufacturer of this aircraft, or the component if it's in the case of the actually original equipment manufacturer, to say, okay, something in your aircraft fell, but it wasn't the aircraft, it was the component itself. So that comes to the word I mentioned originally, to reliability. It's not just reliability of the aircraft, but also all the components that are involved into that. So that's why it's important that you, as aircraft maintenance engineer, um, before you do the certification and when you do this evaluation, you can determine that um, it's based on the data you've been provided, not based on just, obviously your experience is, I would say, 50% of that decision making process, but also the data that you're receiving to give back, so to see why this happened in the first place, why these sort of events happen. I'm not talking in this case for hard landing. Obviously, hard landing could be operational, but also could be due because of the ILS fail and didn't provide proper information to the pilot to make a decision. So we don't know. That's the basic thing, is that it could be, it's too complex to start pointing fingers at that stage. The main lesson here is that you are part of that process of improving the whole fleet in your day-to-day basis. Okay, I hope everyone takes something away from this video about line and base maintenance, and thank you. Let's see.